When we call a function in C or C++ or Rust, what's actually happening under the covers? Let's find out.
Most machine codes don't have the concept of a function call. Instead, you have a linear sequence of instructions which you can jump around. You have memory, which is vast, and you have smaller fixed size bits of memory called registers. So we have to build function calls on top of these fundamental concepts. This is defined in the calling conventions for your platform, which specifies what the registers and stack should look like before the function call, after the function call, and where the return values should be stored. This is essentially like a contract which your compiler will sign to say, here's how you call the functions which I'm going to output. Hey, Milkshake, could you sign the contract? Sign it now.
Now, registers are fixed size, so some things will fit right in a register. Other things like this fish will not, it's too big. So we put this off on the stack, and then we take the fish's address and we put that in the register instead. The calling conventions will designate different registers for different types based on their size, things like that. They can also designate them as caller saves and callee saves. The difference being that callee saves registers will never be modified by the function I call, or if they are, that function has to restore them at the end. Whereas caller saves registers, if I write anything into these, I need to make sure I save them beforehand because the function I call can just throw them on the floor.
The calling conventions are part of a larger document called the Application Binary Interface, or ABI. This will also tell us how to do things like lay out the stack, what the binary representation of different types should be, and things like that, so that we can marshal all the data between functions. The stack is a special part of memory which is made up of stack frames, and most functions are going to get a stack frame which is reserved for their use. This is what it looks like on x64 on Linux. It starts with any arguments which were not passed in registers, then the return address to get you back to the caller, then a pointer to the stack frame for the caller, although sometimes this is omitted for optimizations, and then any local variables which this function needs. So we follow the calling conventions to set up and tear down memory properly so that we can then just jump around our code, and that's how function calls work.